let's just jump right in. If you're building AI applications today, you already know the massive friction of scaling. You start out simple, right? A quick prototype. But before you know it, you're wrangling multiple models, juggling API keys all over the place, and dealing with totally unexpected outages. The complexity ramps up so fast. So today, in this explainer, we're unpacking a really powerful architectural fix that elegantly solves this whole mess. We're talking about the LLM gateway.
Okay, let's set the scene. Picture this. It is 2 a.m. on a Saturday. Your phone is buzzing on the nightstand, PagerDuty is literally screaming at you, your primary model provider just threw a 503 service unavailable error. Now your production app is totally down, and your users? They're staring at blank screens. What happens next? Is your entire team panicking, scrambling to manually swap out API keys buried somewhere in the code? Look, if you're building multi-model apps without a centralized strategy right now, this is your reality. And let's be honest, it is exhausting.
Which brings us to Section 1, the AI integration nightmare.
The contrast we're looking at here is pretty striking. Think about the old way. You start off just importing the OpenAI SDK. Simple enough. But then, a premium customer demands Claude, so you bolt on the Anthropic SDK. Next thing you know, your team needs Gemini for a massive long context job, so in goes Google Gen AI. Suddenly, step back and look at what you're managing. You've got 3 completely different SDKs, 3 totally different authentication setups, 3 custom retry logics, and 3 separate places where your highly sensitive API keys can accidentally leak into some random log file. It's sprawl. Pure and simple. A maintenance nightmare. Now compare that tangled, fragile mess to the new way, one gateway endpoint. Imagine ripping all that code out and replacing it with a single, highly reliable pipeline.
Moving on to Section 2, enter the LLM gateway.
So what is it? Well, an LLM gateway is exactly what it sounds like. It's the reverse proxy your AI stack has been desperately missing. For you backend engineers out there, you already know this pattern from things like Nginx or Envoy, right? It's one single endpoint, usually shaped nicely like the OpenAI chat completions format, that sits directly between your application code and literally every single model provider on the market. Your code talks exclusively to the gateway, period. Then, the gateway handles talking to OpenAI, Anthropic, AWS Bedrock, or even your own self-hosted VLLM. You literally just change a base URL and a model string in your config, and the rest of your app's code, it doesn't have to move an inch. It's such a brilliant mental model.
All right, Section 3, removing the developer pain. Because listen, this gateway isn't just a basic router. It unlocks some serious superpowers that remove huge amounts of developer headache. Remember that 2 a.m. pager alert we just talked about? Well, with a gateway's provider fallback routing, if your primary model goes down, it instantly and automatically retries on a secondary provider. Those 2 a.m. pages, they stop. You get to sleep. But honestly, my absolute favorite superpower here is how it handles costs. We have all heard the horror stories of devs waking up to a massive, totally unexpected inference bill because some script went rogue overnight. With a gateway's cost tracking and hard budget caps, that surprise $4,000 bill gracefully becomes a strict $200 budget that simply returns a 429 too many requests error. Honestly, that massive sigh of relief you probably just breathed, that's exactly why developers love this.
Oh, and it actually gets better for your budget. Gateways use these things called virtual keys. That means you take your one real provider key, lock it securely away in the gateway, and then you just issue multiple revocable virtual keys out to your internal teams. You completely stop pasting your production OpenAI key everywhere. Plus, this sets up another huge win, caching. Caching has become a massive headline feature lately, with vendors seeing an incredible 40 to 60% cut in inference costs on repetitive workloads. By using exact match and semantic caching, if 2 users ask essentially the same question, the gateway just intercepts it and serves the cached response. You skip the API call entirely. That saves time, and it saves serious money.
There are also a few other cross-cutting concerns that the gateway just handles automatically for you, so you don't have to rebuild them from scratch in every single microservice. You get unified observability, meaning it logs every single request, every token count, every dollar spent, all in one centralized dashboard. You also get sophisticated rate limiting and load balancing to spread your requests out across multiple keys and regions, completely smoothing out those super annoying per-provider RPM ceilings. And crucially, you get guardrails and governance. We're talking automatic PII redaction so you don't accidentally leak user data, catching prompt injections before they ever hit the model, and even doing enterprise data residency routing as policy as code. It handles the whole shebang.
Let's look at Section 4, the 2026 Gateway Landscape.
Now, when you're actually navigating the ecosystem to pick one of these, there are some honest trade-offs to weigh.
If you need total control, absolute data residency, or you're running self-hosted models, then the open source and self-hosted options are definitely your best bet. LiteLLM Proxy is wildly popular right now and supports over 100 providers. Or, say you need ultra-low latency for super high traffic production, you might want to look at Bifrost, which is written in Go. On the flip side, if you want zero infrastructure headaches, managed SaaS options give you a full control plane right out of the box. Tools like Portkey give you great control, Helicone is fantastic if you're heavily focused on observability, and Vercel AI Gateway is an absolute dream if you're living in a Next.js web stack. Finally, if you're already deeply invested in your existing cloud architecture, infra-native options like Cloudflare AI Gateway give you amazing edge caching, while Kong AI and AWS Bedrock plug right into the stack you're already paying for. The general rule of thumb here: self-host for control, lean on SaaS to skip the infra work, and go infra-native if edge latency and cloud integration are your top priorities.
But hey, let's be totally pragmatic for a second. You don't always need a setup this complex. If you're just using a single provider, building a single back-end service with pretty low request volume, and you have zero worries about budget, skip it. Honestly, a gateway is just overhead at that really early stage. But, and this is a big but, you need to know that the exact moment you add a second provider, a second engineering team, a real financial bill, or a complex agent, this infrastructure pays for itself on day one.
Which leads us perfectly into Section 5, the agent control plane.
While these gateways mostly just managed basic LLM chat traffic back in 2025, looking ahead to 2026, they are evolving into something much, much bigger. Let's see how this builds into a totally new paradigm. In a world of autonomous AI, the gateway basically becomes the absolute center of operations. The shape we're seeing emerge is this triple gate architecture. Step 1 is your AI gateway. It sanitizes your prompts, routes by cost, and catches any injection attacks on the way out. Step 2 is the MCP, or tool gateway. And this right here is critical. It controls exactly which tools an autonomous agent is actually allowed to call, enforcing strict task-based access control and keeping totally full audit logs of what the AI just did. Finally, Step 3 is your classic API gateway, which protects your internal backend databases and services from the outside world. Think about it. When a single user request suddenly fans out into, say, 20 to 50 automated model calls and tool invocations entirely behind the scenes, you desperately need a choke point that sees all of it. If you're building agents, a gateway isn't just a nice-to-have anymore, it's literally the only way to actually see and govern what they're doing.
So, I want to leave you with a final thought to really ponder. As we rapidly transition away from simple chat interfaces and move towards highly autonomous systems that execute dozens of tasks across our networks, when your agents fan out into 50 separate tool calls modifying live data, who is actually watching them? If you don't have a gateway in place, the terrifying answer is no one. Think deeply about that as you design your next system. Thanks for joining me on this explainer. I hope it brought you some incredible clarity today, and I'll see you next time.
If you found this helpful, hit subscribe and the bell so you never miss a video.